Okay, which fraction is equal to 0.53? This problem is a 4th grade PSSA math problem, and you're not allowed to use a calculator for it. So let's write this number one more time, 0.53. Now you were taught that if you have a decimal and two numbers after it, you're actually supposed to read this as 53 hundredths. Let me say that again, 53 hundredths. Two decimal places after the decimal is a hundredth with a th at the end. So how can I turn that into a nice looking fraction? Well, 53 hundredths is 53 over 100. So 0.53 becomes 53 over 100. And that's it. The depth of the deepest part of the ocean is that number right there. I'm not going to say it yet. I'm not going to say it on purpose. What is the depth in feet of the deepest part of the ocean written out in word form? Let's write that number out. This is what we see. We have 2 digits, a comma, 3 digits. That means once you hit that comma, there's a specific word that pops up, and that word is thousand. Now what happens before that thousand? You just say 36. So what we have so far is 36,000, comma. What do we have after 1,000? Well, we have no hundreds, but we have 70 and no tens, so just 70. 36,070. 36,070, which is going to be B. Okay, A is close, 36,007, nah. Close though. 3,000, nah. 3,000, nah. It's going to be B. The areas in acres of Arches National Park and Great Basin National Park round to the same 1,000 and the same 10,000. The area of Arches National Park is 76,519 acres. Which value could be the area in acres of Great Basin National Park? This is a tricky problem, okay? Arches here is 76,519. So let's write that. Arches, 76,519. What they want you to do is see if it first rounds to the nearest 1,000. Okay, so the way you determine if something rounds to the nearest 1,000 is you go to that 1,000 place value and look to the right of it. If it's 5 or above, give it a shove. So you do, and that becomes 77,000. Okay, so that's going to be the thousands value of arches. Now let's take that same exact number again, and let's round that to the nearest 10,000s, because I have to check for both. I have to check for both. So in order to see if it rounds to the nearest 10,000, you go to the 7 where the 10,000s place value is, you look to the right of it, and if it's 5 or above, give it a shove. So I'm going to do the same exact process with each of these numbers and see if I get 77,000. If I don't, I'm done. If I do, then see if I get 80,000 for 10,000, and if I do, that's my answer. So let's check A. Okay, let's check A, which is 72,658. Start at the thousands place value because that's what I'm doing first. Look to the right of it. 5 or above, give it a shove, gets me 73,000. I was supposed to get 77,000. A is not my correct answer. Let's do it again. Let's try B. B is 76,419. Start at the thousands place value and look to the right of it. 4 or below, let it go, so you stay at 76,000. I was supposed to get 77,000. B is not my answer either. Let's try C. 77,100. Go to your thousands place value, go to the right of it, 4 or below, let it go, and that stays at 77,000, which is what I want. So first check is correct. Now we have to see if this number is going to round up to 80,000. So we'll go to the 10,000's place value, look to the right of it, 5 or above, give it a shove, turn 77,100 into 80,000, which is what I want. Therefore, C is my answer. Very, very, very challenging problem. A student correctly divides a 4-digit number by 5. The quotient has a remainder of 2. Which number could be the digit in the ones place of the dividend? Well, if you're going to have something that you divide by 5, according to the divisibility rules, whatever that word is, it's got to end in either 5. It's got to end in either 5 or 0. So numbers like 4,005 or 3,995 or 8,120, just 20, 0 with a 0 attached. Okay, now they must end like that. So if I were to divide anything with a 0 at the end, I'm not going to get a remainder, no matter what. If I were to divide by 5, anything with a 3 at the end, that would look like something like U, where I would have a remainder of 3. Okay, so you can't end something in 3 and divide it by 5 and have a remainder of 2, because no matter what, because it's either going to end in 5 or 0, and in this case it's going to end in 0, no matter what, you're going to have a remainder of 3. So that's not it. What about 7? Blah, 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 7. Well, if you divide something by 7, you're going to end up with a 5 right here. And when you do that and subtract, you're going to get a remainder of 2 no matter what. So the answer is going to be 7. Now let's just pick a random number and do it. Okay, let's just go over here and pick a random number and do it, and just a random number that ends in 7. How about 2107? And divide that by 5, just for funsies. Okay, 5 does not go into 2, but 5 goes into 21 4 times. 4 times 5 is 20. 21 minus 20 is 1. Drop down to 10. 5 goes into 10 twice. 2 times 5 is 10. Minus 0. Drop down to 7. 5 goes into 7 once. 1 times 5 is 5. Remainder 2. So it'll always work out that way, that if you are dividing by 5 and it ends in 7, your remainder will be 2. If you divide by 5 and it ends in 8, your remainder will be 3. If it ends in 3, your remainder will be 3, so on and so forth. Tricky problem. An office building has 32 floors. There are 98 light bulbs on each floor. The price to replace each light bulb is $2. What is the total price to replace all the light bulbs in the office building? The first thing that we're going to want to do is find out how many light bulbs there are. And we do that by saying there's 32 floors, 98 light bulbs per floor. Let's multiply these together. Now you are allowed to use a calculator for this, so make sure you do so you get your numbers right. And in this case you would get 3,136. Now that's how many light bulbs there are in this building. What we need to do now is find out how much it would cost to replace all of them. Well, each light bulb is $2. So we're going to multiply this number by $2. When you do that, you get $6,272. And so the answer is D. Carrie and DeMarco are reading copies of the same book. Carrie has read 3/10 of the book. DeMarco has read 2/3 of the book. Which sentence about the fractions of the book they have each read is true? All right, let's do this. Let's say that here is the book for Carrie. We'll put a C there. And the same exact size picture, I'm going to try to make it the same exact size. I know it's not perfect, but it's close. Okay, that's DeMarco. Now, Carrie has read 3/10. So let's split this up into 10 parts. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, DeMarco, we're going to split up into 3 parts. Okay? Now Carrie has read 3/10 of it. So as you can see, not a lot. Not half, a decent chunk. DeMarco has read 2/3. 2/3 is me covering in or coloring in 2/3 of it. So DeMarco has read a whole lot more of the book. So what we need to show is we need to show that 3/10 is smaller than 2/3, or 2/3 is greater than 3/10, whichever way works. Now, this is giving us reasons why. So not only do we need to say one of these true statements, we need to say why. Let's look at the true statement first. 3/10 is greater than 2/3? No, the answer is not A. 3/10 is greater than 2/3? No, the answer is not B. Because the numerator of 3 is equal to the denominator of 3, 3/10 equals 2/3? Well, no, that doesn't make any sense. Because 3/10 is less than half the book, and 2/3 is more than half the book, 3/10 is smaller than 2/3. That's our guy. So very tricky problem, very challenging problem, but what we did is we drew it out into these little fraction models, and then we were able to answer our question based off the picture that we drew. Min stretches for 1/12 hour. She runs for 6 times as long as she stretches. Then she walks for 2 times as long as she stretches. What fraction of an hour does Min spend stretching, running, and walking? All right, this is going to be fun. Min stretches for 1/12 of an hour. This is her stretching, okay? Then she runs for 6 times as long. So we could say, all right, well, 6 times 1/12 times 6. But let's write 6 as a fraction, 6/1. 1/12 times 6/1, multiply the numerators, gives you 6. Multiply the denominators, gives you 12. Now, I know you want to simplify that, but let's not simplify that, not yet. Then she walks for 2 times as long as she stretches. So she stretches for 12, 1/12 I mean, and she walks for 2 times as long as she stretches. So multiply the numerators, gives you 2. Multiply the denominators, gives you 12. Now, she stretches for 1/12 of an hour, runs for 6/12 of an hour, and walks for 9/12 of an hour. What fraction of an hour does she do doing all 3? So let's write out all 3 and add them up. So we wanted to keep the denominators the same because you can't add fractions unless they have the same denominator. All right? So when you add fractions of the same denominator, add the numerators just like they are. 1 plus 6 is 7. 7 plus 2 is 9. So you have 9. And then keep the 12 the way it is, 9/12. Now usually we would simplify this by dividing the top and the bottom by 3. But they don't want us to here. They just kind of want us to write it out like that, which is kind of silly to me. I don't like it. You should simplify fractions, but not today. Not today with Min. One piece of meat has a mass of 1.06 kilograms, and another piece of meat has a mass of 1.5 milligrams. Which explanation correctly compares the masses in kilograms of the 2 pieces of meat and gives the correct reason for the comparison? All right, so looks like they want us to use less than or greater than, and then they want us to explain it. So let's write it out in the order that they have it. 1.06 blankety blank 1.5, and leave it at that. Now, if I wanted to, I could write this out as 1.50 and pretend this is money. $1.06 compared to $1.50. Well, $1.06 is less than $1.50. They both have $1. So we need to concentrate on the cents. I know we're talking about weight here, but it's the same idea. So 1.06 is less than 1.5, which means not you and not you. Now, why? Well, it's because 6 is not less than 5. It's because 0.6 is less than 50, or 6 is less than 50. Again, we're thinking money thoughts. Even though this doesn't talk about money, we could treat it like money. 6 cents is less than 50 cents. Therefore, 1.06, which looks like $1.06, is going to be less than 1.5, which looks like $1.50. Sophie and Evan are collecting pennies for school. Sophie has collected 141 pennies. She has collected 3 times as many pennies as Evan has collected. How many pennies has Evan collected? Well, Sophie has collected 141, and she has collected 3 times as many pennies as Evan, which means Sophie has more. So what we need to do is we need to do this opposite. If Sophie has 3 times more, that means in order to find Evan, you're going to divide by 3. So we're going to do some long division. So we need to find out what times 3 is 141, and that's Evan. Now, when you look at the answers, I think you're going to know what it is, but let's just do anyway. 3 goes into 1 0 times. 3 goes into 14 4 times because it becomes 12. 4 times 3 is 12. Write it out. Subtract 14 times 12 and you get 2. Drop down the 1 and you get 21. Now repeat the process. 3 goes into 21 7 times. Multiply 7 to 3 and you get 21. Subtract 21 minus 21 and you get 0. So no remainder. The answer is 47, which means the answer is A. 21. A number sentence is shown below, but a symbol is missing. Which symbol should be placed into the box to make the number sentence true? So we're going to do a little bit of multiplication first and then division and see how that compares to 32. So let's set this up. 16 times 4 divided by 2. If you need to go off to the side and do 16 times 4, that's not the end of the world. 4 times 16 is 24, so write out a 4, carry the 2. 1 times 4 is going to be 4 plus 2 is 6. So we get 64 divided by 2. Now if you need to go off to the side and do 64 divided by 2 using long division, there's nothing wrong with that either. 2 goes into 6 3 times. 3 times 2 is 6. Subtract and you get nothing. Drop down the 4. 2 goes into 4 2 times. 2 times 2 is 4. Subtract and a remainder of 0. So 64 divided by 2 is 32. So if I were to rewrite this all out, I get 32. Then we have that box, and then we have 32. Well, 32 is 32, so we are going to use the equal sign, which means the answer is A. Eric picked 36 apples at an orchard. He packed all the apples he picked by putting 9 apples into each of 4 bags. What is another way Eric could have packed all of the apples he picked? Well, this makes sense. If you have 36 apples and you put 9 apples into 4 bags, 9 times 4 does equal 36. So what this question is asking you is, what's another way that you could set this up so that you could do something times something equals 36? Well, could we do 6 times 6 equals 36? Yeah, and that's actually true. But let's make sure the other ones don't work. 8 times 4, nope, that's 32. 11 times 2, nope, that's 22, the Taylor Swift special. 15 times 3, nope, that's 45. So the answer is right away A, because 6 times 6 is 36. A number pattern starts with the number 7. All right. The pattern follows the rule add 10. What digit in the ones place of the 12th number is in the pattern? Ugh, this is going to take forever. All right, let's add 10, you get 17. Let's add 10, you get 27. Let's add 10, you get 37. Wait a minute. You're in the ones place. You're in the ones place. You're in the ones place. You're in the one. No matter what we do, anytime we add 10, add 10, add 10, you're going to have 7 in the ones place. So no matter if it's the 12th number or if the 70th number or whatever, the ones place number is going to be 7. So our answer is C. That wasn't so bad. A carpenter took some time to gather materials before building chairs. Each chair took the same amount of time to build. The table below shows more time to build the first chair because the time for gathering materials is included. So here's a table the guy took, a couple hours to get some wood and nails and hammers and stuff. And then after 4 hours of gathering stuff and work, he built one chair. After 5 hours of all that, 2 chairs. 6 hours of all that, 3 chairs. The pattern continues. How many chairs will the carpenter build in 10 hours since she began, she is the carpenter, gathering materials? So, all right, well, let's keep going with the pattern on the left. The number of hours is 4, 5, 6, and we need to make it to 10. So 7, 8, 9, 10. On the right side, it also goes up by 1. So 1, 2, 3, so 7 hours is 4 chairs, 8 hours is 5 chairs, 9 hours is 6 chairs, and after 10 hours of work, she made 7 chairs. So that's going to be our answer, 7. Just simple pattern. Keep going with the pattern. Your answer is that. In the picture shown below, the two rectangles have the same length and the same width. So these are the exact same looking rectangles, A, B, C, D, E, F, G, H. Okay, line segment BE will be added to the picture to create additional figures. So let's do that. Here's B, here's E, and we are creating a line segment. Now, a line segment means it has a beginning and the end. So these guys are just connected. It's a perfectly straight line. Okay, they're connected. Which statement about BEHC, so let's draw that out. BEHC is going to be BEHC. Just imagine I can draw straight lines. And BFGC, so let's draw that too. BFGC, so that's this whole thing, BFGC. So we have these two shapes that they want us to know. Okay, which is true? Both BEHC and BFGC will be rectangles. Well, that is true. If you're already adding a rectangle and you have a rectangle next to it, all of the angles are still going to be what's called right angles, which are 90 degrees. So since this was already a rectangle, it's already 90. And since you're 90 and you're next to these guys, you're all going to be 90. So these are all going to be 90-degree angles. So A, right off the bat, is true. Both this purple shape, if I knew how to draw one, and this green shape is going to be, they're both going to be perfect rectangles. In the diagram shown below, figure A, B, E, F, so that's A, B, E, F, and then let's go back and connect it, is a trapezoid. Okay, so we'll talk about what a trapezoid is in a minute. And figures ACB, so ACB is U, and FDE is U. They're both right triangles. All right, so what we have here is we have this red triangle, or this red trapezoid. Here you go. You have this blue triangle that lives inside of it, and you have this green triangle that lives inside of it. Both of these are right angles. Based on the diagram, which statement is true? ACDF must be a rectangle. Now, ACDF, if you are a trapezoid, it means these two sides are parallel and will never touch. Okay, more importantly, these are straight lines. So if you're a right angle, that means you're a right angle. Okay? Now, if you guys are going to connect, and if these are parallel, these are also going to be right angles. Okay, so ACDF must be a rectangle is true. Okay, the other ones won't make sense. They just won't work out. And if you look at the pictures, I know you're not supposed to do that, but if you look at the pictures, you can kind of see why they won't make sense. But A is going to be the correct answer. All right, ladies and gentlemen, we have our first open-ended response question in this practice test. It has to do with time. We will do all parts of this in one video, so make sure you're watching the whole thing. Go back and review if you need to. Ms. Lowry has a rectangular clock shown below on her desk. So imagine this is like a regular clock that you see in bedrooms and stuff like that. Describe the time shown on the clock as the amount of time before the hour. All right, so this is 1:45. Every hour has 60 minutes, right? So what we would do is we would say, okay, well, if they want us to do the time before the hour, we'll do 60 minus 45 to see how much time is before the hour. So you do regular subtraction, okay? Borrow the 1 from the 6, make you a 5. 10 minus 5 is 5. 5 minus 4 is 1. So this is going to be 15 minutes before. Now what comes after 1 o'clock? 2 o'clock. So 15 minutes before 2 is going to be the amount of time before the next hour. Okay, part A, complete. Part B, same exact picture. The rectangular clock face is 6 inches wide. The area of the rectangular clock face is 12 square inches. So all right, let's draw a picture because we can. You are 6 inches wide. Okay. Now, they want to know the height, which we will pretend is the letter H. They tell us that the area is 12 square inches. Now, how do you find an area? You find an area by doing length times width. Here's the thing. They give you the width. So what they're basically saying is what times 6 is going to be the area of 12. So what we need to do is divide. 6 divided by 12 is going to be 2, because 2 times 6 is going to be 12. 2 times 6 is going to be 12. Since it says inches, we are going to say 2 inches. And that's going to be our answer. Part B, done. Part C, Miss Lowry's clock weighs 3 pounds and 4 ounces. Show or explain to find the weight in ounces of the clock. Now, right around now, you look at your formula sheet and find out that 16 ounces equals 1 pound. So if I wanted to do the 3 pounds part, let's do that first. They want us to answer this in ounces. So we would do 3 times 16. 3 times 16, so 3 times 6 is 18. Write out the 8, carry the 1. 1 times 3 is 3, plus 1 is 4. So the 3 pounds is going to be 48 ounces. Okay, On top of that, we need to add the 4 ounces that was already there. So 48 plus 4 is 8 plus 4 is 12. Carry the 1. 1 plus 4 is 5. This whole thing is going to be 52 ounces. 52 ounces. Miss Lowry wants to find the mass of her desk using the smallest whole number possible. Explain whether it would be better for Miss Lowry to use kilograms or grams to describe the mass of her desk. All right, grams are very, 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 very small things. Like if you were to take something like salt, like you sprinkle a little bit of salt, or if you ever look at the back of packages of food, it'll tell you that, oh, there's like 50, like if you drink a soda, there's like 50 grams of sugar in here. It's a very small amount. Okay, so think of a can of soda having so much sugar in it, 50 of it. Okay, now you would need a lot of cans of soda to equal out a desk. So what we are going to use is kilograms. Kilograms is 1,000 grams. So we are going to say it would be better to use kilograms because that is for larger objects and grams is for smaller objects like food or drinks. Okay? So that's that. That's the end of our open-ended problem and the end of our first practice test for 4th grade PSSAs. Make sure you watch all of my videos so that you feel comfortable for the 4th grade PSSAs. Good luck. Thanks for watching.